Good afternoon, everybody, and welcome to NASA's Johnson Space Center. I'm Dan Hewitt. In just a few days' time, 2 NASA astronauts are going to be heading outside of the International Space Station and attach a new gateway that will enable future U.S. commercial crew vehicles to dock to the orbiting laboratory. Here to learn a little bit more about that spacewalk and everything surrounding it, I'm joined by my esteemed panelists here. Just to my right, we have Kenny Todd, the International Space Station Operations Integration Manager. Going down the line, Steve Stitch, the Deputy Program Manager for the Commercial Crew Program. Just next to him, Zeb Scoville, who will be the Flight Director for the Spacewalk. And all the way in the end there is Glenda Brown. She's the Lead EVA Officer for this Spacewalk. As usual, we'll hear from each of them and then open it up for questions here in the room and on the phone bridge and through social media. So with that, we'll kick it off. We'll go ahead and hand it over to you, Kenny.
Thanks, Dan. As you said, certainly a significant week for the space station program and NASA in general. This EVA that we're going to be doing on Friday represents a very significant milestone on the path to establishing a commercial crew capability on board the ISS. So we're very excited. We've had this in the queue for quite a while. As most of you know, we were going to try to do this last summer, but things didn't go our way, and so here we are back again in August of 2016, and we're staring at the IDA daily in the SpaceX trunk, and we're ready to go put it on board. So as far as the internal workings associated with the IDA, we put the control panel in and a lot of wiring back last year and earlier this year. So we've done a lot of work already that's not totally visible to you, and so we're very excited to put this piece of hardware on the front of station and get it all integrated and get ready to go. From a bigger picture standpoint, at the program level, having this capability is really going to help us in general because it gives us a redundancy in our launch services and being able to get crews to the space station, and certainly I think that's a win for everybody in this partnership. So we're very excited to get that milestone checked and get to the point where we can have crews launching from different places around the Earth and servicing the station. In addition to that, commercial crew is also going to give us an opportunity to get a little larger crew on the space station on the USOS, which is going to be a very important thing as we move forward. If you look today at the way the increments play out, a lot of times we'll be running a little short on crew time. That tends to be our pinch point sometimes relative to some of the research that we're doing. So having an extra USOS crew member is going to be very important for us, and that again will be another good thing about having this commercial crew capability. As far as how things are going today, increment 48, things are going extremely well. The USOS crew on board, Kate and Toc and Jeff, are just doing a fantastic job. All of them are really looking forward to this EVA. If you look at their activities over the last week, even some of their downtime, they're still thinking about this EVA, and they're asking questions, and they're wanting to take looks out the window and take a look at the work site. And again, I think that's just part of that giddiness before you get ready to go do an EVA and wanting to make sure that you're as prepared as you can be. And so it's a lot of fun getting to this point where we're right on the edge of going and doing this. So. As far as the SpaceX 9 mission, we've had the Dragon on board since July. The crew's done such a nice job at turning the module and getting all the cargo out and doing the science that we're going to go ahead and try to unberth the Dragon on the 26th, which will be a week from this Friday, and go ahead and bring the Dragon home. And at that point, then we'll play out the rest of the increment with Jeff and Kate and Toc. When we look forward from there into increment 49, Jeff's going to come home with his 2 Russian crewmates around the 6th of September. And so at that point then we'll be in increment 49, and we're still sorting out some of the details of what increment 49 is going to look like. Our Russian friends are still trying to get all their stuff sorted out. In addition to that, our JAXA colleagues are working their HTV dates. They've had some issues with HTV-6, and they're working through that, and they are going to bring us a launch date here in the very near future and help us understand what their intention is relative to launching that vehicle. In addition to that, one of our commercial cargo providers, Orbital ATK, at this point, they are planning to launch their OA5 flight in the latter part of September. And so I bring all that up to say that with these flights, kind of moving out of the early part of September, we're going to take the opportunity to go ahead and do a second EVA on the 1st of September. So what was once going to be one EVA to go install an IDA is now going to become two EVAs, with the primary focus on the second EVA of retracting one of the thermal radiators. You might recall we tried to retract this guy here earlier this year, and I guess it was last year, and we didn't get it totally in, and so we went ahead and redeployed it, and we'll go back here in a couple of weeks and restow that guy for its final time. And then at that point we'll bring Jeff home on the 6th, and then we'll get ready to go do the orbital mission in the back half of September, and then HTV will come at some point after that. So there's a lot going on. There's a lot here in the next couple of weeks, and so everybody's really going to be focused on trying to get through Friday, and then from there on it's just going to be knocking down the dominoes over the next few weeks. As far as the EVA itself, most of you will probably recall that back in January, we had what we can term kind of a water in the helmet event. And so since that time frame back in January, we spent a lot of time trying to understand exactly what happened in that particular EVA, collect as much data as we could with the suit on orbit, and try to go through our standard fault tree investigation, let the data, mark off the different legs of the fault tree. And we've had, I think, a good amount of success in being able to at least work through the different legs of the fault tree. And what's different about this particular event from the one we had back 3 years ago with Luca Parmitano is that we didn't have the opportunity back in 2013 to get that suit back on the ground. But in this instance, we did. We brought that suit home on SpaceX 8 and went into a very detailed test and tear down and evaluation of that suit. We looked at it from a fully integrated suit here on the ground, put a subject in it, tried to recreate the same conditions we saw on orbit, did not see the same thing. Once we convinced ourselves we'd done everything possible with the suit up in its full up configuration, we began to tear down, and we got down to the component level, and everything pretty much passed and was within specification when it was tested. The only thing that I would tell you was a little bit off nominal. There's a piece of hardware that's called a sublimator, and that sublimator is used to help manage the condensation that's in the loops within the suit, and it has a series of holes in the sublimator, and it's through those holes that the water, the condensation, if you will, is carried back and put back in the water loop that circulates throughout the suit. And what we did find was there's a secondary set of holes that had some blockage in them. When you tested the sublimator at its top level, it performed just fine. It was within spec. But I think what we arrived at is that whether or not there was a contribution from this secondary path is something that's going to be very difficult for us to tell here on the ground. And it may be that it's an effect that we just don't see without being in zero gravity. Again, when you test the sublimator and all the primary holes in it with this blockage in place, it still was within specification and worked just fine in terms of removing the amount of condensate and water that it needed to remove. So we couldn't exactly pinpoint the issue to this blockage in this secondary set of holes. But again, we can't say for sure on that just because we don't understand how this hardware in that area reacts in the zero G world. So that was something that was a little bit off nominal. Again, working through the fault tree and this idea that we didn't see the same kind of failure that we saw before. The fan pump set worked great. If you recall, back in 2013, that was the primary issue that we had some contamination that was getting inside the fan pump separator. That was all traced back to essentially a water source, if you will. The water wasn't the quality that we need to be putting in the suits. And so we fixed all that up, and when we got this suit home, we checked it, we ran through the water samples and looked at the fan pump sept, and it looked very good, no contamination issues there relative to the water. So at least we felt comfortable in that we didn't have the same problem we had before, and that's when we kind of honed in that this was, one, not as much water as we saw back on 23. When we looked at other paths where we can get water, that's when the condensation thing became more of a concern to us. So once we identified the holes with the sublimator and then started looking for, the ways that we get condensation in the suit, we took a hard look at the operational way we do business there relative to causing moisture to occur inside the suit, and we hit on a couple of things that we intentionally do with the suits to try to create moisture. On the front end of an EVA, we actually prime it, if you will, a little bit more on the hotter side in order to generate a little bit moisture in the suit, because the moisture is actually very effective in helping us to get our CO2 scrubbers, our carbon dioxide scrubbers up and running and running efficiently. If we can get those scrubbers running efficiently, then that means we can take the EVA out to its full length. If we have a problem with the CO2 scrubber, then we're not going to be able to stay outside. So it's very important that we condition that CO2 scrubber, and so we ask the crews run a little hot early, generates a little more moisture in the suit, and based on the evidence that we've been able to look at and looking at the metabolic rates and whatnot, it looks like we were overachieving a little bit in that area of generating moisture in the suit during that first front part of the EVA. In addition to that, there was also a procedural thing that we did just after we come out of the airlock, where we intentionally asked the crews, and we've only done it for a couple of EVAs, but we intentionally asked the crews to go ahead and switch the temp control valve to where it goes to a full cold setting. When you do that, you effectively are changing the temperature at a rapid pace across the suit. And when you do that, and you've got a lot of moisture in the suit, then you go to a cold situation on the lines, then you're going to generate a lot of condensation at that point. And so when you add it all together and look, we probably were overachieving a little bit when it comes to the amount of condensation we were putting in the suit, and then you couple that with the this potential effect due to this secondary set of holes for allowing the condensation to leave. Maybe there is a contributing factor there. And so at the end of it all, we looked at the fault tree throughout the program. Everybody got comfortable that that was our primary cause and contributor in this whole event. From that point, we went to an agency level review that was chaired by the head of human exploration and operations, Mr. Bill Gerstenmaier. He had his counterparts participate as well from safety and engineering at the agency level. And at the conclusion of that, they agreed and concurred with the program that we had looked like we had identified the proximate cause, and that and with the mitigations that the ops team had put in place, that it looks like we figured out a way to still be able to get the right amount of moisture in the suit, but make sure that we don't do it in a way that we're putting too much moisture and potentially overwhelming this sublimator function. So after that meeting, which was last week, we came out and put our nose to the grindstone and got ready in the operations world to go do this EVA. This morning we did the mission management team go, no go, and everybody was go. We had a good, robust discussion there, and at this point the team is ready to go, and we'll go do it on Friday.
All right, over to you, Steve. Thanks, Dan. It's great to be here this afternoon representing the Commercial Crew Program. We are extremely excited about the upcoming EVA on Friday to install the International Docking Adapter. If I think back, the last time a vehicle undocked from this area of the space station where we'll do the EVA
was the Space Shuttle Atlantis 5 years ago, closing the door on that chapter of the incredible Space Shuttle program. And now we're about to embark upon these test flights in the very near future next year to get the 2 new commercial vehicles, Boeing CST-100 spacecraft and SpaceX's Dragon spacecraft flying back to the International Space Station. We very much look forward to getting this docking adapter installed, and the second docking adapter. It'll really be that gateway or new door to open up the space station to these new commercial vehicles, and as Kenny talked about, enhancing the science with an additional crew member. If you look at what's happening all across the country in commercial crew, it's just an incredible time frame. We have hardware being built all across the country. Both SpaceX and Boeing are building their test vehicles, their structural test articles to go into testing. And this really gives us confidence that these vehicles can operate in the demands of the spaceflight environment, both for launch and landing and on orbit. We're embarking upon parachute tests all across the country. Both providers have done initial tests this year. We look forward to more tests later on this year to test those very critical systems. We have environmental testing going on, and just a host of components all across the country are being qualified for these 2 spacecraft. We're in what I would call the very, very difficult, hard phase of development where we're trying to qualify the spacecraft to make sure that it works in the environment and for this very important space station mission. If you look at the Kennedy Space Center, you'll see a transformation both at the Atlas Launch Complex 41 and then SpaceX's Complex 39A, where we used to launch both the Space Shuttle and then before that Apollo missions. Even today, as we speak, at Complex 41, the crew access arm, so that very important last arm that the crew will walk over into the White Room and get into the CST-100 spacecraft, is actually being installed there at Complex 41. It's about a 90,000-pound piece of structure that spans about 50 feet and was lifted up today and is being bolted into place. If you drive a little north up to the Pad 39A area, SpaceX has a big crane installed, and they're in the process of retrofitting a Pad 39A. They've installed rails to bring the launch vehicle out to the pad. They've modified the flame trench. They're modifying the fixed service structure for the space shuttle, and they'll have a crew access arm going into place as well very soon. You can see a big hangar for SpaceX right next to Pad 39A. And then if you go across where space shuttles used to be processed, Boeing has the C-3PF, their commercial facility to process their spacecraft down in Florida. And then if you turn to the training operations, we've selected 4 astronauts, Sonny Williams, Eric Boe, Bob Behnken, and Doug Hurley, to begin training and preparing for the test flights. They've been working hand in hand with our NASA team and also the Boeing team and SpaceX team on laying out the cockpits, on laying out the displays, and been intimately involved with the design and the testing for these vehicles. And so they've been flying back and forth all across the country. In terms of rocket engine testing, just recently we've had the RL-10, which is the upper stage engine for the Boeing vehicle, underwent a hot fire this weekend. Both the engines have been hot fired for the crew flight test rocket. So lots of activity going on. It's really an exciting time for us. It's an exciting time for the entire team. We're excited to see this tangible change in the space station. Space station's been changing for the last year to get ready for our flights. And now once we have this new door on the front of the space station, I think for us, it really marks it's time for us to get our hardware ready to go fly. Our teams are excited all across the country, both the contractor and NASA. We're excited about the Spacewalk Friday, and we're looking forward to it and looking for great test flights next year.
All right. Thank you, Steve. We'll go over to Zeb now, start getting into some of the nitty-gritty about this spacewalk and what the crew's been doing to get ready for it.
Great. Thank you very much. I'm Zeb Scoville. I'm going to be the lead flight director for this upcoming EVA number 36. And as has been mentioned, the prime objective of this spacewalk is really to get this international docking adapter installed to the front of the pressurized mating adapter number 2. And so to help visualize this, if I can roll the first video, please. So the stage was set for this upcoming spacewalk over the course of 4 previous spacewalks. 3 were completed by Terry Virts and Butch Wilmore, and then 1 was completed by Scott Kelly and Tim Copra. And they literally ran hundreds of feet of power and data cables from node 1 along to the lab and node 2 to the PMA2 area. And that provides us the power and utilities required to make the docking adapter functional. Coming up this Wednesday evening, the robotics team from the ground will control the station robotic arm and using the special purpose dexterous manipulator, reach into the Dragon trunk and pull out the docking adapter from within the Dragon and maneuver it and position it over in front of the PMA2 about 3 feet away from the interface. It'll stay there for a couple nights until the day of the EVA. During the morning, while the crew is getting suited up and getting into the suits, the ground will then position the docking adapter close to within contact of that surface so that it's ready in position for the crew when they get outside the door to get there. This will be actually the first time that the EV crew has been able to have a direct interaction during a spacewalk with the special purpose dexterous manipulator. So it's a good sort of handshake between our robotic and human elements outside building the space station. Spacewalk number 36, as I said, will take place on Friday. The crew is planned to get out the door about 7:10 in the morning. And when they do this, we'll have Jeff Williams as EV1. He'll be wearing the suit with the red stripes. And Kate Williams will be EV2. She'll be having the white stripes on her suit. For Jeff, he is one of our most experienced astronauts, and this will be his 4th career EVA. His first EVA was on STS-101 on an Atlantis mission to the space station, and that was a mission to prep the station for the first crew arrival later that year to inhabit and live in the space station. He then later did 2 EVAs during increment 13. One was on the Russian side, and then 1 US spacewalk. For Kate, this will be her first spacewalk. She's been training for this particular EVA literally for years. She's putting a lot of time in the ground, in the pool, and on orbit getting ready, and she is very ready to go and execute this EVA, and she's going to do just great. I'd also like to mention Q Onishi, who is going to be helping out with the crew in the morning, getting the crew suited up in their suits, ready to get out the door. And then he doesn't have much chance to rest. We put him right to work in the Node 2 area. Inside there, we have a control panel, which drives the mechanisms and the hooks to physically mate and connect the docking adapter to the pressurized main adapter. And so there's a very coordinated interplay between the external crew outside, TOC on the inside, and the ground doing the commanding. And so he plays a critical role in really making all of that come together. On the ground, organizing all of and orchestrating all of the procedures is Tom Marshburn, himself a veteran of 4 spacewalks, and he's going to be able to lead the crew through those EVA procedures and really keep them on track and focused. As I said, prime objective is to get that docking adapter installed, hooked up, and checked out. Once it's connected, there's some additional tasks to outfit it. We have some thermal covers we're going to remove and install. We also have some mirrors that we're going to set up. These mirrors are used as reflectors for upcoming vehicles. As they're approaching the station, they can reflect a laser off of them, and that provides relative navigation during the approach and rendezvous phase of the missions. After that, of course, we'll call a successful day. There's still more work to be done, though, prepping for the next docking adapter coming up. And the crew will go and route some cables along the lab up to the Node 2 area. Jeff Williams will go back to the Node 1 area, and there's some additional cables that will connect some Ethernet and power out to a future EVA that's going to happen in the next year or so. That's all I've got. I'd like to hand it over to Glenda Brown now.
Thanks, Zeb. So we couldn't be more excited to be participating in the final EVA that's required to bring in the new capability of the docking system. We spoke to the crew this morning. They've completed all of their procedure reviews and they are really ready to go. They've even looked at all the contingencies. We talked with TOC as well to coordinate all of the communication that'll be required to drive the hooks as we make the adapter. And so they're in good shape. Everybody's ready to go. Zeb already mentioned the statistics on the crew members and how experienced they are. It's worth pointing out that Kate also helped in a lot of the early development of how the cables would be routed for these various tasks. As you know, it doesn't just take a crew member and a couple of people up here saying how we're going to do the EVA to make it happen. There's people all over the country that have been working on this, including the contractors that have been providing the tools and the hardware and the spacesuits. The EVA project office, Maria Tuller, integrates all of that for us. She's the lead for us and represents a whole bunch of people, and we really appreciate all of her hard work. Then there's all of the training that we're doing. For this particular EVA, we've done training over at Building 9 at the POGO, or Partial Gravity Facility. We also went into the Virtual Reality Facility in Building 9. And of course, the Neutral Buoyancy Laboratory. We did a lot of training there and a lot of development. Tom Marshburn was key along the way. He helped us out with the development of all of the timelines and preparation of the training so that by the time that the assigned crew got to the task, we had it all ready to go and we could just get right directly into the water, teach them exactly what they needed to do, and be able to do this thing on orbit. We also have the robotics team. It's led by David Grunt, the robo-operator. He represents the Canadian Space Agency and all of the work that they do with the dexterous end effector. I'm going to refer to that as Dexter for the rest of the presentation. And then the OSO team, Adam Mendoza leads the effort for this spacewalk. There is a whole team of people that have been working with him on all of the integration of the control panel and the docking adapter itself. For my team, I've got representing the systems and the EMU work, the spacesuit itself. Mark Wilsey and Alex Kanalakos will be following the airlock systems in support of the EVA. Dave Barrett is going to be helping out on the task side, and then I have to extend a really special thanks to Brian Mader, who is the task lead and has been working with me for the last 2 years to get ready for this EVA. We're ready to support. With that, let's go ahead and roll the video, and I will show you what we're going to be doing. We start out our EVA at the Quest airlock. Jeff will be EV1. He'll be coming out wearing the red stripes, and Kate will hand out an ORU bag to him that contains all the IDA tools. She'll egress, and then they'll begin their translation forward out to the very forward end of the space station to do their work. Jeff will translate around the starboard side of the external stowage platform number 2. He'll wait there just a moment while Kate finishes her initial translation adaptation and then translates over the top of the stowage platform out to pick up her foot restraint, which is on the very forward edge of the ESP2. Once she's got that, Jeff will translate forward on the lab and that up over the top of the node 2 and finally onto the PMA2 that's at the very forward end of the space station. He'll position the ORU bag on a couple of handrails that are right on the zenith side of the PMA, and then open the bag so that they've got access to their tools and equipment. In the meantime, Kate begins her translation. She's going to translate up over the top of the lab, and then forward onto the node 2, and finally forward onto the PMA2, where she translates down toward the nadir side and locates the socket where her foot restraint will go, or worksite interface. Once she has her foot restraint set up there, she'll be able to access the cables that were pre-positioned by Butch Wilmore on a prior EVA. They're tied off to in a bundle to a couple of handrails that are located on the PMA. While she's getting set up, Jeff will also get his foot restraint and get it set up. It's currently located on the top of the Columbus module. He'll retrieve it from there and then move it down to his worksite interface on the PMA, which is more zenith and a little bit toward port. From there, each of them have access to be able to reach their cables. Jeff's cables have also been pre-positioned on a prior EVA. Terry Burtz left 2 bundles of cables there for him to access. Once they get into their foot restraints, they can attach their adjustable equipment tethers loosely to the IDA. Kate has 1 adjustable tether, and in order to be able to reach between the handrail and the IDA-2, Jeff actually has 2 tethers in series. When they're in position, they'll give the go to the robotics operator on the ground to release the IDA-2 and back the Dexter arm away. At this point, the crew has complete control of the IDA. They'll cinch the tethers down into place, and then they'll begin mating the cables. This is Kate's cable configuration on the nadir side. Here we see her at the neutral buoyancy laboratory practicing those cable mates. And while she's mating her cables on the nadir side, Jeff is mating his on the zenith side. He has 3 cables to initially mate. These cables are providing heater power to the docking adapter, as well as the hook drive power and the sensor power. The switches will be commanded by the internal crew member, IV crew member. TOC will work at the IDA control panel, which is in the node 2 pressurized volume. As he operates the switches, it commands the hooks that are on the docking adapter to extend out, rotate around, and engage the passive hooks that are on the pressurized mating adapter. There's 2 sets of hooks, and while they drive the first set of hooks, the crew needs to remain still. But during the second drive, it's stable enough that they can begin work installing a cover on the hemi-reflector that's on the nadir part of the PMA-2. Then they're into their final cable mates. These final cable configurations remove the power from the hooks that we're driving to engage the PMA and provide visiting vehicle hook power. Here you see Jeff working in the neutral buoyancy laboratory. He's removing a couple of jumpers that are required to do his final cable mating. Once the cables are mated, they have some outfitting to do. First, they'll be covering up the H fixture that the Dexter robot arm was holding on to. Then there is another hemi-reflector that is on the PMA. They'll install a cover over the top of it and then move the tether that was holding that cover in place up to tether to the large protective cover that's covering the IDA-2. That was in place for launch in the SpaceX Dragon. There are several straps that they need to work together to remove. It's very similar to the PMA covers that we've been installing and removing in the past. Here you see Kate working in the NBL to remove the straps from the handrails holding it in place. The 2 of them need to work together to stuff that cover into the ORU bag. At that point, they can install the 2 hemi-reflectors onto the docking adapter, and then the final thing that they need to do is mate up the visiting vehicle power. It's one final cable configuration that needs to be made. Jeff will complete that mating, and at this point, that docking adapter is ready to receive our new crew vehicles. The crew can pack up and clean up this work site. Kate will pick up her foot restraint and return it to the ESP2 from whence it came. Jeff has to pack up the ORU bag and also return his foot restraint. His foot restraint goes back from where it's located, where he's been using it on the PMA. He'll take it back up to the top of the Columbus module. It'll be staged there in place for the IDA-3 installation that will be happening in late 2017. They return the ORU bag back to the airlock and then go out, Kate will go out to the lab nadir to a bag that's already there and route the cable for IDA-3. We call it the white-green cable because we put some tape measures, some tape marks on it in white and green to indicate which one it is. She routes it forward to the node 2 where it's in position for the IDA 3 installation. Jeff has some work to do back in the area where the Z1, the node 1, the node 3, and the lab all come together. We refer to this area as the rat's nest because of all of the cables and electrical lines and fluid lines that route through that area. He'll pick up the cable bundle that was left in position at the end of EVA 35. He'll make a couple of connections down on the node 2 and then route that cable across the Z1 tray over to the starboard side of that tray and then leave it in position there where it will be ready for its final routing on a future EVA. The last scheduled task for this spacewalk will be to remove a couple of caps from some connectors that are located just underneath the Z1 on the outside of the node 1. At that point, the crew will return to the airlock and ingress. If we've been particularly lucky and efficient throughout the day and the hardware cooperates, rather than ingressing the airlock, we've got a couple of get-ahead tasks that we can do. One of them is to configure the port CETA cart. We'll tie down the brake handles to keep them out of the way for long-term operations on station. And then we also want to get some photos of the alpha magnetic spectrometer. From the windows and from all the cameras on space station, we cannot see the outboard side of the AMS. And we'd like to get some photos of that area, see how it's doing, so they can get those photos from the top of the logistics carrier that's located right next to it. That's all I have for the video. I did bring a couple of show and tell items here. I've got a 3D printed PMA2. This is a representation of the IDA2. And you can kind of see how they go together. The Dexter robot arm holds on to it by this H fixture that's over here, brings it into position. As Zeb mentioned, on Wednesday, the robot operators on the ground will command it into a position that's about 2-3 feet away, something like this. And then on the morning of the EVA, the robo operator will push it all the way into contact, we hope. So once it's settled down into position, the cables that are mated, the ones that are on the zenith side kind of go to a panel back here. The ones that are on the nadir side go to a panel over here. And then the cover that I was mentioning goes right over the top, and it's strapped down to these handrails that are along the side. Here's one of the hemi-reflect. This is the planar reflector on the PMA2 that we have to cover up. We'll add a hemi-reflector over at this location, so those two would interfere with each other if we didn't cover one. So only one needs to be visible at the time. And then there's another hemi-reflector over here that we're covering because its functionality is then taken up by the hemi-reflector that gets installed that's over on this side. So that's the configuration that we'll leave it in. And then just to give you an idea of how it gets used in the future, this is a NASA docking system. This piece of hardware would go onto the front of the visiting vehicles. Each visiting vehicle needs to have a piece of hardware like this. It's got some motorized actuators inside it, and they extend out this docking ring. So this extends out, and then it actually has targeting software in the visiting vehicle itself that as they come in, it points the docking ring. It would adjust so that it lines up completely flush, and as it comes in, then it sucks right into position. And that is how how it will connect to the new visiting vehicles. Then that ring can be retracted, and then the same switches that we're using to install the hooks that'll hold the PMA and the IDA together, they use that control panel is now reconfigured, and that's how the latches are configured, are driven on the PMA2 to engage the, on the docking adapter to engage the new NASA docking system. This is flight type like hardware of the control panel itself that's located inside the node 2, and that's the IV operator on board that will be switching the switches to be able to engage the hooks. That's all I've got, so I think it's time for questions.
All right, thank you, Glenda. And as she said, it is time for questions, so we'll go ahead and open it up here in the room first. If you are on the phone bridge and you have a question, just a reminder, please press *1 to get into our queue, and you can always press *2 to withdraw your question if it gets answered. As usual, I'm going to go left to right. Mark?
Oh, thank you, Mark Carreau, for Aviation Week. Once you've finished the Spacewalk installation, are there other additional activities or operations that need to be done internally or externally for this particular IDA to be functional, or is it pretty much ready?
So there are some additional just checkouts that are done after the crew comes inside, finishing closing out of the control panel, as Glenda mentioned, and then just verifying the heater activations and checking out the hooks for the adapter that would mate with the visiting vehicle. So there are some checkout activities, but not a significant amount of work, and it can be done IVA and scheduled at any time. And we'll probably knock out most of it within that evening. And some of it can be done from the ground as well.
And if I could ask a second question, it would be the current plans for the launch of the second IDA. I think you talked about maybe installing in late 17, but I'm not sure how that matches up with the delivery plan.
Right now, our plan is probably more likely leaning towards early 18 at this point, is when we'll try to fly the IDA-3. We're trying to sync that up with our launch schedules. As you know, this particular piece of equipment, the only option we have for getting into space right now is on the SpaceX Dragon. It's in the trunk. And so we're in the process of syncing up those schedules, but it's more likely going to be early 18 before we'll see it on orbit.
Okay. Gina?
Gina Sinceri, ABC News. Tell me a little bit more about the interaction between the astronauts and Dexter. How much contact and interaction will they have?
Well, this is the first time that the EV crew members have actually taken a handoff from the SPDM. And the SPDM itself is very sensitive to external loads. In space, it's got a lot of capability, but on the ground, it really can barely support its own weight. So we have to be very careful about putting loads into the SPDM, particularly, so if it's being held over here by the H fixture and a crew member on this side is holding onto a handrail here, he's got a long moment arm there, so he really has to limit his loads. As I mentioned in the presentation, the plan is for the SPDM to move it all the way in down to contact. If for some reason that doesn't work out, or maybe it can't quite get onto the fine alignment pins, there are big course alignment guides, there are also fine alignment pins. If it's just resting on the top of those, the EV crew might have to take the handoff directly from the arm rather than having it already strapped down, in which case they just attach a retractable equipment tether, and then they very just fingertip motion receive the IDA from the SPDM. So nominally, it should already be tethered. They'll come up, put their tethers in place between the tether point and the handrail, and just take out the slack. It's kind of got an adjustable cam buckle on it, not unlike your luggage really. Cinch it down just enough so it's not loading it, but just enough to hold it in position. Then the SPDM backs away before they cinch it down. In the off-nominal case where we haven't been able to bring it all the way in, then they would just receive it with just fingertip motion or strength on the handrails until the SPDM releases. It takes about 6 minutes for the ungrasp operation, and then a few more minutes for it to back away. And then once it's clear, then they can bring it down into contact and cinch the tethers.
Robert Perlman with CollectSpace.com. Just to verify with regards to the IDA and Dexter, if you run into trouble with the installation, whether it's with the hooks and latches or whether with the cables, can the IDA sit there with between the first and second EVA? Do you have to reattach Dexter? What's the
Yeah, and we've gotten the thermal information back on it, and thermally it's going to be good to sit there, even if we didn't have a chance to mate the heater cable. If the heater cable is mated to it, that's just all the better for it. It can be held in place just by those two adjustable tether locations. As I said, it's two in series on one side and just one on the other. So a total of 3 tethers really holding it into position. And it can take all of the loads from space station, docking loads, debris avoidance maneuvers, all of those really high loading events can all be handled, at least for a short period of time, a few weeks, just by those equipment tethers themselves. If for some reason the hooks didn't drive and we had no luck and we needed to come back inside and come out another day, in that case we would take the long duration tie-down tethers. They're rated for the duration life of station if required to hold it in position. And it also, those could make sure that it stays cinched up really tight so that Ivy could potentially do some additional troubleshooting with trying different switch configurations and so on to try to drive it if we can't get it done during the EVA. We've got a lot of contingency plans in place, though, to get it done during the EVA. We're going to make it happen.
And if I can ask a follow-up. With regards to IDA 3 and starting commercial crew operations, do you need to have a second IDA on station as a backup before you can launch a commercial crew vehicle, or are you good to go with just one?
Yeah, we committed a while back that with one IDA on station, we were going to be declared ready to support commercial crew, and we'll get the other IDA up there, and like I said, in 2018 we'll get it hooked up. We'll have a little redundancy there.
And I'll clarify. Yeah, we've looked at it. Both SpaceX and Boeing are planning for the initial flights, their test flights, to dock to this IDA that we're installing on Friday. So they're all set up for that. Over the life of station, obviously we need both adapters there. There'll be a few times where we'll have both commercial crew vehicles on the space station, so we'll need both adapters there. But for the initial test flights, it will be acceptable to just fly with IDA 2 on the Ford location.
Okay, it doesn't look like we have anybody on the phone bridge yet. Again, if you do have a question, just press *1 to get into the queue. So why don't we go to social media real quick, take a quick question from some of our followers.
We have a question on Twitter from the Sunshine Girl. How long will the spacewalk last? If it takes more than 6 hours, can the astronauts drink or eat in between?
Well, that's always a fun question. We plan all of our EVAs for 6.5 hours, with a few exceptions where we think it might really take a little bit longer. And then we make sure that the program buys into all of the potential risk of extending. Spacesuits are designed for 6.5-hour EVAs. So we've planned for that, and if we have extra time, we'll fill it up with those get-ahead tasks that I mentioned. And the crew does have a 36-ounce drink bag, so they can drink water. It's just plain water, and they can drink all of that till it's gone. And there is no food. There is no food. But they practice that way. In the neutral buoyancy laboratory, when we do our training on the ground, those are 6-hour training runs, and so the crew is well used to that.
Got another one?
Yep. Another one on Twitter from Steph Faulkner. Do you get at all worried about suit failure on spacewalks, or do you have total faith in your checks?
Well, I'll tell you from a suit failure standpoint, I think over the last 3 years or so, we have certainly been brought back to the realization that after using these suits for the better part of 30 years, that we're still learning. And so we approach every EVA, and I think the ops guys will tell you this for sure. They check and double check, the different contingency scenarios to make sure that we are ready to deal with any potential failure that happens in the suit. And again, we're still learning. We're still learning how to use this suit and how to care for them in the zero gravity environment. And it's not the same as we do here on the ground. And so it's still very much a learning process, and we have to be aware of that, and we have to account for that. And when we go do our spacewalks, and we're doing that.
Yeah, I like to call it a healthy fear. It really drives you to make sure you've dotted all the I's and crossed all the T's, that you really understand what you're up against.
All right. See if we have any follow-ups here in the room. I think, Mark, you got one.
I do, Mark Carreau for Aviation Week. I think this is for Glenda, and sorry, it's a couple term questions. You mentioned Hemi reflector. Could you kind of explain what that function is? And then mentioned white-green cables, and this may fit in actually with a larger question of what sorts of utilities are you putting where when you do the spacewalk cabling?
Okay, so first of all, on the Hemi reflectors, Zeb mentioned this just a little bit in his presentation. So on the PMA right now, there's a planar reflector that's kind of located on the top, and then the Hemi reflector, Hemi in that it's half a circle or half a globe, is located down here on the nadir side. Okay, and it's actually a series of little mirrors that reflect the targeting laser from the visiting vehicle. So even now, our visiting vehicles use those. The HTV uses that system as well, and that's why we need to make sure that the one is covered before we install the new one that's on the IDA2. If both of those were there, that would be confusing to the targeting system on the visiting vehicle. So we need to make sure that just one is visible by the visiting vehicle. And then the white-green cable. So Zeb mentioned that we have pulled power and data from all over the space station, and we've routed on all of these prior EVAs power and data from all over the space station, kind of collecting. Nobody planned for this kind of docking adapter when we designed the space station. So we picked up available feeds in pass-throughs that were already existing, or like the power that we used to use for space shuttle, we picked that up to use also. So in order to keep track of which cable was which in the bag, we ended up color coding them. And so each of the cables we tie down with wire ties, and we attach tape flags to each one of those, and wrote down on the tape flag what it was, and then we colored them in with Sharpie markers. And the one that we're routing on the lab nadir is tagged with white, green striped flags, and that's why we refer to it as the white-green cable. It also helps us keep track of them because there are so many different power and data lines. It's very hard to just refer to them as power or data or whatever because you'll get them confused. So that's why we use the color coding.
But they'll provide power and data as a final extension for this?
Yes, yes. So white-green cable goes to the IDA3 and provides power and data to IDA3.
Okay, we do have one quick question on the phone from space.com. Go ahead.
Sure. What sort of challenges could the astronauts face when installing the new docking adapter?
So there's some standard challenges that we always face. Our connectors on orbit tend to be more difficult than you wish they would be. So whenever they're mating those cables, they have to very carefully position it, and then there's some tricks of the trade to wiggle and jiggle it just right to be able to get it to mate. In the past, we have had trouble with some of those, particularly cables that have been on orbit a long time. These have not been on orbit that long, so hopefully that'll work just great. Another thing that, little things get in our way, things like the foot restraint joints. We need to be able to point the foot restraint right where we need to go. Those joints can get sticky if they're particularly too hot, too cold. Sometimes they'll get sticky, so we've got a contingency ready to go get another one from another location if needed. The installation of the wire ties, it can be pretty hand intensive. So if the crew member is struggling early with the connectors, for example, then later in the EVA it could be very fatiguing to operate the wire ties to tie those cables down to the handrails. So those are kind of some common challenges that would be reflected on this EVA, or could be. Alternatively, if the hook drive doesn't go well for whatever reason and we need to go to the backup plan, all that work is done by the IV crew member and the ground. All of that troubleshooting on driving the hooks, all we can really do is go back and check the connector, make sure it really got mated well. So while they're off doing that, we'll send the crew off if it looks like we've got time to start working on those other cabling tasks that are at the end of the EVA or potentially one of the get-aheads, depending on how much time we think we're going to have.
Okay, Samantha, did you have a follow-up?
Nope, that's it.
Did you have one, Robert? Okay, go.
Robert Perl with Collect Space. It was mentioned that one of the benefits of commercial crew is increasing the amount of people on board, adding another USOS crew member. There was a report out of Russia last week that Russia may be thinking about reducing its crew by one, and that they had notified the partners. Can you talk a little bit about what they had notified and what the plan for that might be?
I think as much as we've heard is probably what you yourself have seen in their press, which is they're exploring the option of going down to 2 crew on the Russian segment, and they've made that known to the partnership. One thing that we certainly always keep in the back of our mind that our Russian partners are committed to the program for at least through 2024. So there's no doubt they're keeping that in mind as they work through whatever challenges they have within their system. They brought that forth as an option. We'll look at it as we do with all these kinds of things. We'll trade it against whatever risk that might put into the program. First and foremost, the risk to our crew on board and the station itself. And then from there we start looking at the options and see what we can do as a partnership to try to either accommodate it or help them realize why that's a bad thing. But at this point, it's strictly a proposal they put on the table, and we'll look at it.
All right, well, that's all the time that we have for today. I want to thank you for tuning in. I want to, of course, thank all of our speakers here today walking us through this spacewalk. Going to be very exciting. You can, of course, watch it live on NASA TV as it unfolds on Friday. Coverage will start at 6:30 a.m. Eastern, 5:30 a.m. Central. As you heard Zeb say, they should be heading out of the airlock hopefully around 8:10 or so Eastern, 7:10 Central. So be sure to tune in for that. Stick around right after this briefing, see the road to IDA, some of the steps that we've taken to get here. And thanks again for tuning in.
Over a period of 4 spacewalks in 2015, NASA astronauts laid the groundwork for the installation of the first International Docking Adapter, or IDA, on the International Space Station. The first 3 spacewalks were conducted by Butch Wilmore and Terry Virts, who unfurled hundreds of feet of power and data cables needed for not only 1, but 2 docking adapters that will serve as future docking ports for U.S. commercial crew spacecraft in development by SpaceX and Boeing. Saturday, February 21, 2015, focused on Pressurized Mating Adapter, or PMA number 2, to which space shuttles used to dock, and where the first IDA is being attached as the primary docking port for the first commercial crew flights. Working on the forward end of the Harmony module, Wilmore and Virts played out 10 different cables in some of the most labor-intensive work in station history. After unfurling the first 8 cables and prepping the last 2 for the next spacewalk, the crew members called it a day. 4 days later, on February 25th, the pair headed back outside and routed the remaining cables to PMA-2. With their primary job complete, the pair split up for additional station maintenance tasks, including preparations for the relocation of the permanent multipurpose module as part of the reconfiguration of the station to accommodate commercial crew vehicles. After another 4-day breather, Wilmore and Virts suited up one final time to install the Common Communications for Visiting Vehicles, or C2V2 system, a relay system for data and communications between approaching commercial crew vehicles and the station itself. Working in tandem, the NASA spacewalkers hoisted 2 antennas on the station's truss structure before routing 4 separate 100-foot cables to a single connector located on the U.S. Destiny laboratory. Then, last December, right before Christmas, astronauts Scott Kelly and Tim Kopra took up the cause, routing yet another cable that will be used for the installation of the second of the docking adapters to the space-facing side of Harmony. The two docking ports will provide redundant parking spaces for U.S. commercial crew vehicles that will augment the transportation of astronauts to and from the orbital outpost and the expansion of research capability on the International Space Station.